week, what we have learned is first principle. Okay, it's about the limit. We learn limit first, and we learn what is defined limit exists, continuity, and then we go to exercise A to talk about the limit. Why we talk about the limit is because the limit will help us to find the derivatives for any function by using first principle. And you know that like first principle is this formula here. F dash x equals to lim h approaching to 0, fx plus h minus fx divided by h. Okay, by using this formula, I can find the derivatives for any function fx. Okay, but what we talk about today is like I go through exercise B at the beginning. So what we talk about today is you are not going to use first principle to find the derivative for any single function. Okay, there are some patterns for like, for example, polynomials. And year 12, you'll learn what's the derivative for circular functions, for logs, for exponentials. You'll learn that later. In year 11, we focus on polynomials. Okay, we focus on polynomials. You're not going to use that, okay? If it's like to the power of 3, yes, we can still do it. If it's to the power of 5, we need to expand and then cancel and then divide by h and substitute h to 0, like to the power of 5. No, we are not going to do that. So it's too difficult to do. What we're going to do is learn the rule for it. Okay, all the x to the power of n, okay, all the fx equals to x to the power of n. Doesn't matter what n belongs to, okay? N belongs to R. N can belong to any real number. They all follow the same rule, which is f dash x equals to n times x to the power of n minus 1. Okay, they all follow the same rule. And the x must be a single x. It's not going to be 2x plus 1. Okay, it's not going to be 4x plus 5 to the power of 3. Okay, it must be a single x, so it's purely x to the power of n. And then the derivative is n in the front times x to the power of n minus 1. And then we talk about this table here. A constant must have derivative equals to 0. Why a constant's derivative will be 0? Let's just think about fx equals to 2. We can think in two different ways. First, by looking at the graph. Second, by looking at the formula. So if you look at the graph, fx equals to 2 is just a horizontal line. Okay, it's just a horizontal line. If it's a horizontal line, the derivative is 0 because it's talking about the gradient. For a horizontal line, the gradient is 0. Okay, there's like flat. There's no rise. Okay, the run can be anything. There's no rise. Okay. The second, we look at the formula. Okay, we look at the formula. The formula is fx equals to 2. Okay, there's no x involved. If there's no x involved, we say that's x to the power of 0. Okay, x to the power of 0. So that's 1. Okay, x to the power of 0 is 1. So therefore, using the formula is fx equals to 2 times, okay, 0, x to the power of negative 1. Then that is just a 0. That's f dash x. Okay, that is just a 0. Because the power is 0, when you bring the power down, that just becomes a 0. So the derivative for constant is 0. Okay, by both looking at the graph and using the formula. And then we say, if there's a constant time with x, okay, it's not the constant to the power of something, it's like 3 times x to the power of something. You just keep the constant in the front, okay, just keep the constant in the front, and then you derive x to the power of n as normal, and you times the constant. If it's two functions add together, you can differentiate them separately. If it's subtraction, you differentiate that separately. But, okay, but the times will not be differentiate them separately and times them. Okay, the times will using product rule, which we'll learn later. So it can only use by plus and minus. Okay, not going to have times and divide. So I ask you to do all your homework. Let's just check the answer together. First of all, you have fx. You're not going to directly write that's 12x to the power of 2 minus 2. You need to write f dash x equals to that. You need to make it very clear. That's the derivative equals to that. Okay, so times the 3 drag into the front, time with the 4, you have the 12, and 3 reduced by 1, you have the 2. Okay, and a linear. maybe it's easy to think about just the linear. The linear got power of 1, so you drag the power down, it's still that constant, and then the power reduced by 1, it becomes a 0. So that's a 1. Okay, so we may just add another line here. Ax, the derivative is just a. Okay, ax, the derivative is just a. Okay, you don't really need to think that much. Okay, for this one, f dash x equals to 22 just become a 0 because it's a constant. And then minus 5 on 8 times 4 times x to the power of 3 plus 3 on 4 is the constant times 3 times x to the power of 2. That's minus 5 on 2 x to the power of 3 plus 9 on 4 x to the power of 2. Okay, that's the derivative. You're just checking your answers. You should do this before today's lesson. Okay. When I have two function times together, okay, fx times gx, that's you can't do like separately derive and then times. So this notation will be dy dx. You have y equals to some x, then you have dy dx. So dy dx equal, we need to expand first. Sorry, we need to expand first. So still y equals to 2x squared plus 4x minus 3x. So you have a plus x and minus 6. Okay, that's expansion. And then they all becomes plus or minus. Then we have 4x plus 1. Okay, 4x plus 1. Okay, next one. Next one, we need to adjust the power. Okay, adjust the power. So y equals to 2 times x to the power of negative a half. 2 times x to the power of negative a half. And I don't really care what is this constant. Well, if you want to change it to powerful, you can do that. It's 5 to the power of 2/3. Okay, 5 to the power of 2/3. X times 2 times x to the power of negative a half plus 5 to the power of 2/3. And then we say dy dx equals to 2 times negative a half times x to the power of, well, negative a half minus 1 is negative 3 on 2. Okay, negative 3 on 2. And then this is the constant, just becomes 0. Okay, that's the constant, just becomes 0. So what we have for dy dx is minus x to the power of negative 3 over 2. Okay, if you want to put in positive indices, so that's negative 1 over x to the power of 3 on 2. Okay, you can put in this form as well. Well, if you want to do even further, you can say that's x to the power of 3 and then take square root. Or you take square root first and then to the power of 3. Okay, that's D. And the E, we talk about that, we need to separate it first because that's a division. Okay, a function divided by a function, I can't do that. So that's 2 to the power of 3 over 4 times t to the power of 2/3 plus 3t over 4 times t to the power of 2/3 minus 1 over 4 times t to the power of 2/3. And then I can simplify it. That's a half t to the power of, okay, 7 on 3, 9 on 3 minus 2 on 3, that's 7 on 3 plus 3 on 4 times t to the power of 1/3 and minus 1/4 t to the power of negative, that's a 2, okay, 2 on 3. It's a negative 2 on 3. You flip it up, become negative. And then we'll say that's dz dt. Okay, dz dt. A half times 7 over 3 times t to the power of, okay, subtract by 1 is 4 on 3 plus 3 on 4 times 1/4, 2/3, 1, 3/4 t to the power of negative 2/3. Okay, minus 1, and then minus 1/4 times negative 2/3 times t to the power of negative 5 over 3. Okay, minus 1 becomes 5 over 3. And then you simplify it, that's 7 on 6 t to the power of 4 on 3 plus 1/4 t to the power of negative 2/3 plus 1 on 6 t to the power of negative 5 on 3. Okay, that's the simplest form. Okay, so that's E. Okay, that's E. And for F, as I said, for F, this notation together is just means derive this function according to X. Okay, derive this function according to X. So that is already means the gradient. Okay, that already means the gradient of this function. So you can directly write the equal sign and say that's a 9x to the power of 2 minus, okay, this is minus 4x to the power of negative 1. So that's minus 4 times minus 1 times x to the power of negative 2. And then you have the plus 1, it's just a 0. So that's 9x squared plus 4 over x to the power of 2. Okay, so this is the importance is the notation. Okay, it's the notation. The notation just like this whole thing means is the derivative of the inside function. So you will write equal sign. You're not going to say oh dy dx. There's no y. Okay, this notation means differentiate that function. Okay. Example 2. For each of the following curves, find the coordinates. Okay, read the question carefully. It's not asking to find x, it's asking to find the coordinates. The coordinates of the points on the curve at which the gradient of the tangent has the given rule. Okay, I want the gradient to be 8. Again, gradient means dy dx or f dash x. Okay, gradient just means fx or dy dx. Well, when they say gradient equals to that, it's f dash x equals to that. And it's the gradient of the tangent. Okay, it's the gradient of the tangent. So I will find f dash x first. That's 3x to the power of 2 plus 0. Okay, plus 0. The 2 is just a 0. So 3x to the power of 2 equals to 8. X to the power of 2 equals to 8 over 3. And x squared equals to plus minus 2 root 2 over root 3. X equals to plus minus 2 root 6 over 3. Okay, 2 root 6 over 3. And then we have substitute. Okay, f 2 root 6 over 3. I want to find the y coordinates. Okay, that is 2 root 6 over 3 times 2 root 6 over 3 times 2 root 6 over 3 because it's to the power of 3 and then plus 2. So what I will have is 2/3 times 2/3 is 8 over 27. Okay, 8 over 27. Okay, 2/3 times 2/3 times 2/3. And you have root 6 times root 6 times root 6. You have 6 times root 6. And then you plus the 2. Okay, if you can't just do the cubic directly, you can do it by my way. You just times every single thing together. So times 2 to 2 is 8. 3 is a 27. And the root 6, 2 root 6 is a 6. And times another root 6. So 6 root 6. Divide by 3, that's a 9. Divide by 3, that's a 2. And that equals to 16 over 9 root 6 plus 2. And that's the coordinates, 2 root 6 over 3, comma, 16 on 9 root 6 plus 2. And the negative is very easy to think of. That's just negative 16 over 9 root 6 and plus 2. Okay, because that become negative, is become a negative of that. So it's negative 16 on 9 root 6 plus 2. Okay, next one. Next one, I want gradient equals to 0. Okay, have a look at this function. This function is quadratic. If I want a point gradient equals to 0, that must be the turning point on quadratic. Okay, have a think about that. The gradient must be 0 at the turning point. or point of inflection. We will talk about that later. But have a think about the tangent line on the turning point. It's just a horizontal line. So that's when gradient becomes 0. So I will predict that x equals to 2 because I can see completing square, you have x minus 2 squared. Okay, x minus 2 squared. So the turning point exists when x equals to 2. So, well, I will use the derivative method to do it. That's 2x minus 4. Okay, 2x minus 4. And then 2x minus 4 equals to 0. X just equals to 2. Okay, it is 2. Okay, it is 2. So y equals to 4 minus 8 plus 2. That's minus 2. So it's a 2 minus 2 is the coordinates. Okay, it's the coordinates. Okay, 2 minus 2 is the coordinates. Well, also by completing square, have a think, by completing square, that's y equals to x minus 2 squared. Minus 4 plus 2 is a minus 2. So the turning point is 2, negative 2. Okay, 2, negative 2. It is the turning point. Okay, it is the turning point. Okay, last one. G dash x. That's a 0 minus 3x to the power of 2. I want the gradient to be negative 6. X squared needs to be 2. And then we have x equals to plus minus root 2. Okay, plus minus root 2. And let's think about g root 2. G root 2 is 4 minus root 2 times root 2 times root 2. So that equals to 4 minus 2 root 2. So the first coordinate is root 2, 4 minus 2 root 2. G negative root 2 just equals to 4 plus 2 root 2. Because minus 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 overall will give you a minus, and then in the front the minus become a plus. So that is a plus 2 root 2. So that's negative root 2 for plus 2 root 2. Okay, is answering, you need to answer for the coordinates. Okay, that's exercise C. Okay, that's exercise C. Just check your answers. Okay, next one is exercise C. Last one is B. And exercise C, I'm going to do the first principle with you together for this one. I hope you try this one and find it's a little bit hard, and then we can just do that together. Okay, at least you need to try first. By first principle, okay, if it's by first principle, the first thing you write is lim h approaching to 0, fx, well, I would say f dash x equals to that. Fx lim x plus h minus fx, and then divide by h. Okay, that's always the same for any first principle. Okay, first principle is just this formula. And according to what is your fx and fx plus h. So your fx is 1 over x. Your fx plus h is 1 over x plus h. Okay, just substitute the thing in the bracket into the position of x. And then I'll put that together. Lim h approaching to 0, 1 over x plus h minus 1 over x over h. What do you think you need to do first? Well, I need to simplify it. Basically, I can't substitute h equals to 0 now. How I can simplify it? Well, if I ask you to do something, what you should do? Well, like, if that's the question, like, ask you to simplify, it's not going to look like that. The numerator just not looks very correct, okay? It's a fraction. So I need to try to simplify the top first. Okay, if I have two fractions subtract each other, you need to find the common denominator first. Okay, that's always the thing. Find the common denominator first. What I will do is, I will say that is 1, that's x over x minus x plus h in the bracket, x times x plus h. Okay, that's only the numerator. And I'll times the 1 over h. I'm not going to put it on another fraction. So the divide by h at the bottom is just times the 1 on h. Okay, as this is the numerator. Okay, that's the whole thing here. And then the divide by h makes a 1 on h times a 1 on h. Okay, that's how I separate it. You can put h still under the denominator, but I just think it's not that good to put fractions over fractions. And then I will keep going this side. That's lim h approaching to 0. Have a think. Let's make denominator x times x plus h. So this one got the 8x on top. This one got x plus h on top. So what I'll have is x minus h over x times x plus h times 1 over h. And that is lim h approaching to 0 minus 1 over x times x plus h. It get cancelled. Okay, the h and h get cancelled. Now it's nothing wrong to substitute h. That's minus 1 over x times x, so it's x to the power of 2. Well, that h equals to 0, that's x times x, so it's x squared under the bottom. So that is a minus x to the power of minus 2. Then have a think. That's fx equals to x to the power of minus 1. So f dash x, by using the formula, is minus 1 times x to the power of minus 2. And that exactly looks what we have here. Okay, that's the same as what we find here. So the first principle is like, no, the formula is actually coming from the first principle. You should get the same answer. If you get different answers, that's definitely wrong. Okay, that's definitely wrong. Let's have a look at example 3 first, and I'll give you some time to do example 2 by yourself. Okay, because it's the same as the first one. Okay, it's pretty much the same. Let's do the example 3 first. I need to put things in power form. So that's 2 times x to the power of negative a half plus x to the power of negative 5 over 4. Okay, 5 over 4. So f dash x equals to 2 times negative half times x to the power of negative minus 1, that's 3 on 2, minus a 5 over 4, x to the power of negative 9 over 4. Okay, 5 over 4, negative 5 over 4 minus 1, that's negative 9 over 4. So that's just negative, well, if I want, I can put negative 1 over x to the power of 3 over 2 minus 5 over 4 x to the power of 9 on 4. It just looks a little bit better. Okay, just a little bit better. I just put the negative power in the denominator. We only learned one rule in year 11, and we did this like in the previous exercise, and we keep using it. Okay, we'll talk about the derivative graphs later. This one. Okay, again, this one is not good. That's something divided by something. Okay, not divided by a constant, it's divided by some x. So I need to say fx equals to 3 over that plus x over x to the power of 3. Okay, that's something over something. A over c plus b over c. And that equals to 3x to the power of minus 3 plus x to the power of minus 2. So that x and that get cancelled, is 1 over x to the power of 2. And then the next line will be f dash x equals to minus 9 x to the power of minus 4 minus 2 x to the power of minus 3. That's minus 9 over x to the power of 4 minus 2 over x to the power of 3. It just looks a little bit better. Well, it's nothing wrong to keep your answer in the second line, second last line. Okay, it's nothing wrong to keep it like the second last line, but I just want to put in a fraction form. It's more makes sense for me for negative power and the denominator. Okay, so I will give you some time to think about example 2. Well, example 2 needs a lot of calculation, but it's pretty much the same as what we did in this exercise. Okay, just spend some time practice on first principle. You need to use the a plus b to the power of 3 to expand things in this question. Okay, a plus b to the power of 3 to expand things. Okay, let's have a look. So f dash x equals to lim h approaching to 0, fx plus h minus fx over h. Okay, that's the first principle. And that's lim h approaching to 0. X plus h is 1 over x plus h cubed minus 1 over x cubed over h. Okay, everyone did this step correctly. I'm very glad. And then the next step is all correct as well, because I show you the first example. So that one should be x to the power of 3, x plus h to the power of 3. That's the common denominator. And then this term needs to time with x to the power of 3. Minus this term needs to times that. And then you need to times 1 over h at the back as well, because you divide by h. Everyone got this step, okay? And then we need to expand. That's the terrible part. Do not expand the bottom, because you can substitute h directly with the bottom. There is nothing wrong with the bottom, so you can just ignore that. You just need to worry about this h. So this h will get cancelled with that thing. So you just need to worry about those two, how you can get cancelled with that h. So what I need to do is expanding the top. That's x cubed minus x cubed plus 3x squared h plus 3xh squared plus h cubed over x cubed x plus h cubed times 1 over h. Well, you need to have the bracket, and every sign will change to negative. Okay, that's some of you make mistakes. The sign is wrong. Then following that, lim h approaching to 0. Okay, let's have a look what I have on the top. That's a minus 3x squared h minus 3xh squared minus h cubed over x cubed x plus h cubed times 1 over h. Okay, every term got h in this one, and then get cancelled with that h. So go another step back and say h minus 3x squared a minus x squared minus 3xh minus h squared. Okay, I can factorize the h out. And times 1 over h with that. I just factorized h out. So this h will get cancelled with that h. Okay, those two get cancelled. Now I can substitute. There's nothing wrong with the h anymore. Okay, and put h in. That's 0. That is 0. So the top is minus that over. Okay, that is 0. So it's x cubed times x cubed. So it's x to the power of 6. That is minus 3x to the power of 4. You need to double check, because you know what is the derivative. It's x to the power of negative 3, right? So it's minus 3x to the power of minus 4. And it is this. Okay, and it is this, which is correct. And then the question asks you, show that the derivative always negative. So you want to show this number is always negative, regardless what is the value of x. So you say, when x belongs to R, any real number, x to the power of 4 belongs to R plus union 0. Well, I can say that's 0 to infinity. Because it's even power, so negative all turns into positive. So it can be any positive number and 0. If x is, well, x can't really be 0. I can say that's r plus. Because x can't be 0. So excluding 0, x to the power 4 belongs to r plus. Because in your notation, the 0 is excluded already. So negative divided by positive equals to negative. So minus 3 over x to the power 4 belongs to r minus. So it's always minus. Okay, that's kind of a little bit explanations. Okay, kind of a little explanations. Okay, that's it. So we finish exercise B and C today. Thursday we'll go through D. Okay, some cool graphs.